Hello everyone, hope all of you are doing fine. Welcome to another video from my channel. In my last video we talked about differentiating functions in the form of y equals ax to the power n, where its derivative or dy by dx is simply an x to the power n minus 1. Now if you haven't seen the last video yet, I would really suggest you to look at it, where the link will be given in the description below. Today, however, we will be learning techniques that can be used in differentiating more complicated functions in the form of either y is equals to f of g of x or y is equals to f of x whole to the power n, which is the chain rule, or y equals to f of x into g of x, or y equals to uv. It's the same thing, just in different format, which is known as the product rule. And lastly, y is equals to u by v, or function of x divided by g of x, or the quotient rule. So to begin, let's look at the chain rule. So the chain rule should only be used when we have a function in the form of f of g of x, or y is equals to f of x whole to the power n, just like as given in the previous examples. So the formula will be dy by dx would be equals to dy by du into du by dx. So let's consider the example y is equals to 2x square plus 1 whole square. Now if you compare it with y is equals to ax to the power n, you will notice that these are actually not even in the same format, and therefore we cannot just directly use dy by dx is equals to anx to the power n minus 1, because it does not follow the same kind of format. So for these kinds of problems, we have to assume that this guy right here is actually u, and then use this formula, ultimately leading to this formula, and then multiplying with du by dx, which is a different thing. So to solve these kinds of problems, we say let u is equals to 2x square plus 1. Now according to the formula, we have dy by du and du by dx. Therefore we can find out the du by dx here, which is basically differentiating u with respect to x. And according to the formula, dy by dx would be equals to anx to the power n minus 1. We apply the same kind of principle, and we will notice that it becomes 2 into 2x, and since 1 is not an x term, therefore we can write it being plus 0, because when you differentiate any kind of constant which does not contain any x terms, we get 0, as discussed in the previous video. Now further simplifying, we get 4x, as 2 into 2 is equals to 4, and now we have found du by dx. So the next step would be to find out dy by du, and to find out dy by du, we first have to write y in terms of u. Now initially we assume that u is equals to 2x square plus 1, therefore y will be simply u square, and when we apply dy by du, we get 2 into u, and 2 minus 1 is 1, so you don't really need to write 1 as a power. Now applying the chain rule, we get dy by dx equals to dy by du multiplied by du by dx, which is basically 2u into 4x. And now we express the value of u in terms of x, which is initially given as 2x square plus 1, so we get 8x into 2x square plus 1. Now you can further simplify this by expanding the brackets. So you also might say that, okay, what if we expand the brackets in the function and then apply this formula? So in order to do that, we have to expand the brackets and apply the a plus b whole square formula, which is a square plus 2 into a, which is 2x square, into b, which is 1, plus 1 square, and simplifying through it gives you 4x to the power 4 plus 4x square plus 1. Now if you apply the original formula of dy by dx equals to a n x to the power n minus 1, which is also discussed in the last video, then you get 4 into 4 x to the power 3 as 4 minus 1, and that 4 into 2x, and since 1 is a constant we can write it as being 0. Now further simplifying, we get 16x to the power 3 or x cubed plus 8x. Now if you notice with the previous method we used, if you just take a common factor of 8x here, you actually get the same result just like before, hence proving that the chain rule is valid. Now hopefully this example cleared your confusions, but nevertheless we will do some further examples so that we can understand how to use the chain rule efficiently. So the question goes, find the derivative or dy by dx if y is equals to this. So just like in our previous video, we will solve this systematically and in the easiest way possible. So for number 1, we have to find out d dx of 1 plus 2x whole to the power 4 and apply the chain rule. So to start, we can write u is equals to 1 plus 2x. Remember, we are just writing the inner part of the function itself as being u, so du by dx would be actually 2, as 1 is a constant, and y would then be u to the power 4. So applying dy by du, we get 4u to the power 3 or 4u cube, and then we multiply together to find dy by dx. So we simply get dy by dx equals to 2 into 4u cubed, which is 8u cubed, and then further simplifying back to in terms of x, we get 8 into 1 plus 2x whole to the power 3 or cube. If you remember the original formula for ax to the power n, we have dy by dx being equals to a n x to the power n minus 1. Now we can use a similar kind of technique for this chain rule questions. So an easy way of solving these kinds of chain rule problems would be to differentiate the whole thing as x. For example, let's consider these being x. So if you differentiate x to the power 4, you get 4x to the power 3 or 4 minus 1. So we can write that being 1 plus 2x to the power 3. Now since we have only differentiated the outer function, which is 1 plus 2x whole to the power 3, so now we have to differentiate the inner function, which is 1 plus 2x. So further simplifying, we get 4 1 plus 2x whole to the power 3 into 2, and we get the same exact function as we have gotten using the bigger version of the chain rule. Now let me write this again in a clear way in the short version so that you can understand. So the easier method is actually differentiate this thing as x and then differentiating the internal function, which is 1 plus 2x, and we get 8 into 1 plus 2x whole to the power 3. Now for number b, we can use the similar kind of procedure, which is d dx of 3 minus 2x square whole to the power minus 5. Now using the same kind of rules, we get minus 5, assuming this is x, and when you differentiate x to the power minus 5, you get minus 5 x to the power minus 6, because minus 5 minus 1 is equals to minus 6. So we now write that being 3 minus 2 square whole to the power minus 5 minus 1, which is minus 6, and then we multiply with the derivative of the internal function, as I mentioned before, 3 minus 2x squared. So further simplifying, we get minus 5 3 minus 2x squared whole to the power minus 6, keeping this part same, and then multiplying with the derivative of 3 minus 2x squared, which is minus 2 into 2x, which is basically 4x, so we get minus 4x here. So if you're confused about this part, the derivative of 3 minus 2x squared will be, this is 0, as 3 is a constant as has no x terms, and then minus 2 into 2, which is 4, and 2 minus 1 is basically 1. So therefore you have minus 4x, and when you simplify it further, you get 20x multiplied by 3 minus 2x squared whole to the power minus 6. So for number C, we have ddx of root over 7 minus x. So since it is not in its index form, we have to convert it back to its index form by writing it as a power, which would be half according to indices rules. If you remember, a root a will be a to the power half. So using the same rule as before, we get half, assuming this is x, so 7 minus x whole to the power minus half, as you are subtracting half with 1, and then multiplied by the ddx of 7 minus x. So solving this, you get half 7 minus x to the power minus half, and then the derivative of minus x will be minus 1, so this is important, and hopefully you don't miss the negative sign, and the final answer would be minus half into 7 minus x whole to the power minus half. Or you can also write it in its non-index form, which would be minus 1 by 2 multiplied by root over 7 minus x. If you have a to the power minus n, then you get 1 by a to the power n according to indices rules. So for number D, we have the fourth root of 21x cubed subtracted by 2x plus 1 by x. So this might look a bit complicated, but we can actually use the same kind of formula or the same kind of strategy just like we solved the previous ones. It's very important to write every term in its index form so that it becomes easier to apply the calculus formulas. So you have 1 by 4 here, and then you apply the chain rule. So if you have x to the power 1 by 4, you have 1/4 of x to the power minus 3 by 4. This is because 1/4 subtracted by 1 is basically minus 3 by 4, which I showed in my last video. So applying this same tactic, we get 1 by 4 x to the power minus 3 by 4. And now you have to multiply it with the derivative of the internal function, which is 21x cubed subtracted by 2x plus x to the power minus 1. So you get 1/4 of 21x cubed subtracted by 2x plus x to the power minus 1 to the power minus 3 by 4. Basically just copy this thing and then multiplied by the derivative of 21x cubed, which is basically 63 x squared subtracted by 2, and then minus x to the power minus 2. This is because, as shown in my last video, if you differentiate x to the power minus 1, you get minus 1 here, and then x to the power minus 1 minus 1, so you get minus x to the power minus 2. So finally, simplifying everything, we get 1/4 of 63 x squared subtracted by 2 and subtracted by x to the power minus 2, and then multiplied by 21x cubed subtracted by 2 plus x to the power minus 1 whole to the power minus 3 by 4. And so number E, we have 3 divided by root of x plus 2 into x squared minus 3. And first of all, as usual, we have to convert everything into its index form, which is 3 into x plus 2 into x squared minus 3 whole to the power minus half. And if you notice here, we can expand the brackets and we get d dx of 3x into x squared will give us x cubed, 2 into x squared will give us 2x squared, so we write that first, 2x squared minus 3x, x into minus 3, and then finally 2 into minus 3 will give us minus 6, and then whole to the power minus half. So now we apply the same rule, assuming this is x. So just like before, if you differentiate x to the power minus half, you simply get minus half here, and x to the power minus half minus 1, so you get minus 3 by 2. Also, just as a note, why is this so? It's mainly because, as explained in my previous video about fractions, you need to make sure that denominators of both numbers are equal. So here you have minus half, so the denominator is 2, and since there is no denominator here, basically it's 1, so we can make that 2 here by multiplying and dividing both sides by 2 and not changing the number itself, and then subtracting them together gives minus 3 by 2. So using the same format, we get 3 into minus half, this guy, which we considered being as x, minus 3x minus 6 whole to the power minus 3 by 2, and then multiplying it with the derivative of the internal function, which is this, which is x cubed plus 2x squared minus 3x minus 6. And finally we have minus 3 by 2, the same thing, x cubed plus 2x squared minus 3x minus 6 to the power minus 3 by 2, and then multiplied by the derivative of these terms, where it is 3x squared plus 4x, because 2 into 2 is 4, and then minus 3, and we're done with number E. And for the last math, if you remember, they have given us y is equals to 1 by 4x plus 1 whole square, and they've told us to find the value of dy by dx at the point 0.25, 0.25. So let's first of all find out the value of dy by dx, which is number 2. So we have y is equals to 1 by 4x plus 1 whole square. So first we need to convert this into an index form, which will be 4x plus 1 whole to the power minus 2, and then applying the dy by dx formula, which will be assuming that this is x, so as usual, so if you differentiate x to the power minus 2, you get minus 2 here, and x to the power minus 2 minus 1, so we get minus 2x whole to the power minus 3. So using the same kind of principle, we get minus 2 4x plus 1 to the power minus 3, just like I showed, and then multiplied by the derivative of the internal function, which is 4x plus 1. So finally we get minus 2 4x plus 1 to the power minus 3 into 4 minus 8 4x plus 1 whole to the power minus 3. Now they told us to find the value of dy by dx at the point 0.25, 0.25, which is the x coordinates and the y coordinates. Therefore we only need to place the value of x in our expression and we will get our final answer, which is dy by dx is equals to minus 8 4 into 0.25 plus 1 whole to the power minus 3. Now if you know, 0.25 can be written as 25 divided by 100, and dividing both sides by 5 or even 25, you get 1 by 4. So we have 4 into 1 by 4 here, so which is basically 1, and 1 plus 1 is 2, so we get minus 8 into 2 to the power minus 3. Now according to our indices rules, 2 to the power minus 3 is basically 1 by 8, or simply 1 by 2 cubes will be equals to 2 to the power minus 3, and we get 1 by 8, and finally 8 into 1 by 8 is basically 1, so we get minus 1. So this brings us to the end of the video. Hope you understood how to utilize the chain rule and how to apply the formulas without any confusions. If you enjoyed the video, please make sure to leave a like, subscribe, and share this video to your friends. Just to sum up, the chain rule should only be used when we have a function in the form of y is equals to function of g of x, which is another function, or in the form of function of x whole to the power n. The main formula goes dy by dx is equals to dy by du multiplied by du by dx. So hopefully see you next time, guys, for the remaining techniques, product rule and quotient rule. Take care and goodbye.